Hello, today I would like to show you how to get a core line out of a text, something like these text surfaces. And this method is called skeletonization. By using a method of skeletonization, you can get a single line font out of the font surface, which is pretty useful for fabrication usage or anything else. And the algorithm itself is pretty simple, though I need a lot of coding here in Grasshopper if you want to do it in Grasshopper. So that's the topic that I'm gonna tell you today. So before getting into that, let me just explain what kind of algorithm there are for the skeletonization. There are many algorithms for it already. Some of it are used for the image processing. Some of it could be used for the inside the CAD application. And the one that I'm gonna use today as an algorithm is this one using the distance function. So the basic idea is to get the ridges out of this by using the distance function. Now if you hear distance function, I'm not sure if you're familiar with it, but it is the function to calculate the distance in between two points. And the most famous one, if you're in architectural field and if you're using Grasshopper, you might have used it already, which is a Voronoi diagram. So in this tutorial, I'm going to use the Voronoi diagram to get the ridges of that Voronoi diagram to get the single line, single font out of the font surface. So here's a sketch of the diagram of the algorithm. First you have this kind of surface, font surface on number 1. And number 2, we're gonna scatter some points on top of the outline of the surface to make it as a center point of the Voronoi diagram. Then use that points to create a Voronoi on top of inside this text surface. Then remove the edges which is touching on the outline of this text, which gives you which you are left with the center core line of the text, and that is the method you can get the skeleton out of the text surface with this algorithm. So let's do that. I mean, it looks simple enough. I think some of you might be able to do it in Grasshopper without using any coding, but in some cases you need to consider about some graph theory in order to remove the edge which is touching with the outline of the text cleanly. So mainly that's the things that I'm gonna use coding in Grasshopper. So let's get going. I'm gonna make a new file and let's get started. Now first of all, I need to draw a text outline inside Grasshopper in order to create a core line first of all. So to do that, there aren't any like a default component which draws the text. So for that purpose, I have to write my own code in order to draw the text with a specified font inside a Grasshopper. So to do that, first thing you need is a list of font that you can use in this Grasshopper file. So let's first get that by creating a C# script. And I don't need any input, I just need a list of fonts. So let's name this fonts as an output, and let's get inside here. And let's write some code here. Now I am going to create the text a little bit bigger so that I can see better. Something like this, yeah, alright. Now, the list of fonts can be retrieved by using a system.drawing.text.installed font collection. And what you want to get is name of the font. So first of all, I am going to get the font families from this installed font collection. Right, and then I'm gonna create a list of string to store all the names of the font. And I'm gonna go through all the font families to get the font names and store it inside this list that you have just created. Okay, I think this is the right name. Okay, I got some errors here. Fonts. Okay, I'm using the same name here, so I have to change this. Font names. Right. Okay, still have some problem here. Line 59. Okay, I have to say new. Right. Okay, now that I have stored all the font names inside a font names list, I'm going to output it inside as a font names, capital F font names. Okay, let's see if it did work. Yeah. So now I got the list of font names like these. Now I can choose one of the font from this list to actually draw the font outline. Alright, so let's give a list item. List item to just pick one of the font name. And I guess I'm just gonna get Arial, just a basic font. Right. Let's check this out. Right. Okay. Now that I got the font, what I want to do next is to actually draw the text using this font. So let's create another C# component to do that, because there are no default components to do that. So we're gonna need to write this down using Rhino Common API. Right. So let's create some input here. First of all, position of the text and text itself. We're gonna need a font as well, and then maybe we would also need a size. Okay, I guess these are the minimal parameters that you need to in order to draw the text. Okay, so the position, I'm gonna set it to say plain, which is this. Where is it? would like to use the plain, this one. Okay. For the text, obviously this is string. Yeah, for the font name, this is also a string, and the size, this could be double. Right. Now I'm gonna connect this Arial, which is the font, to the font. For the text, I'm gonna just write random, like world, something like hello world. If you are using other than English, like font, like Japanese font or Chinese font or Korean font, you can just use that word as well. But for this tutorial, I'm just gonna stick with the English characters, alphabetical characters. Right. And the position, I'm just be fine using the XY. Right. Now for the size, let's just use like random size, like 20 for now. Right. And for the output, I'm gonna make one output called outline, which will be the outline of the text. Okay. Now let's get inside. Now let's try to write some code here in order to draw the text with a curve, outline curve. Okay, so in order to write the text, we're gonna use this text command in Rhino. And in Rhino Common API, this is called text entity. So let's start by creating a new text entity. New text entity. And we're also gonna create a font in order to use it inside the text entity. So text font new Rhino doc objects font, and we're just gonna have to feed in the name of the font, which I have it here from the parameter. So I'm gonna write it like this. Now for the text entities, actual text, I'm gonna use a plain text. I'm gonna feed in this text that I want to draw, which is come from here, like this. And I also would like to set the position of the text entity. The position is called plain, I guess. Plain, yeah. And the plain, the position is this one, the position parameter. So I'm gonna set it to pause. Let's also set a justification, which you can choose any justification. I am just gonna set the most well used one, which is this bottom left. Right. And let's also set the font with the font that you have just created. And finally, let's set the size. And the size is defined by text height. Like this. Okay. Now let's create an outline out of this text entity, which is pretty easy to do. You can just call text entity dot create curves. Okay, and you have to set the style dimension style, which you can retrieve from the text entity itself. So text entity dot dimension style. Right. The other option that I have to set is if you want to allow this text to be opened. No, I don't think so. And other parameters are optional, I think, so I'm just gonna leave it closed like this. And finally, I'm gonna output this outline from the outlines output. Outline, this one. I didn't need the S. Like this. And let's see if it worked. Yeah, it worked just fine. Okay, looks good, looks good. Let's also try writing some like Japanese characters if it still works. Like rather complex one. Yeah, still works. And as you can see, for Japanese characters or Chinese characters, you have tons of like this kind of holes here, which looks hard to realize the skeletonization, but actually the method that I'm gonna show works in any kind of text, so that's pretty useful, I think. So let's just leave this Japanese font, Japanese text as it is to see that it still works even with those complex characters. Those of you who don't have a way to type the Japanese characters or Chinese characters, that doesn't really matter. Just use the English, just use the alphabetical characters. Right. Now that I have got the outline, the first thing I would like to do is to create a surface out of this outline. So let's create a boundary surface for an outline, right? And then I'm gonna graph this, and from this each surface I'm going to create a edge again. I'm doing this because in order to like retrieve the data structure of which corresponds to the surface and the curve. So that's the reason why I'm not gonna use this outline as it is. Right. So for the naked edge, all the curves should be naked edge, I think, for these curves. So I'm just going to join them to create as continuous curve. Sometimes from one surface you get two curves when you have a hole. If you don't have a hole, then you just get one outline out of this join curve. Right. Now, next thing I would like to do is to get the... So if in the algorithm that I showed here, I want to scatter points on top of this outline of the text. So that's what I'm gonna do using a divide curve. Now, in order to use the divide curve, I need to set the count number for the outline, but I want to keep the distance between the points somehow consistent for all the characters. So you might think it might be better to use divide lengths, but this has its own problem. If you use it, it's okay for most of the part, but as you can see here, close to the end point, you have distance that is sometimes it's too close, depending on the number of the length that you enter. So to make the whole distribution the same size, same distance, I'm going to do like this. First, I'm going to calculate the distance of the curve, then divide, do the division, this curve length with some base value that you want to use for the division of the curve in order to divide the curve with this distance. And then you'll have some value here, and you just want to enter this resulted value into a count of divide curve, and as a result you'll get somehow a consistent distance between the divided point for whole edges. Now, yeah, and this works pretty well, right? Now, okay, now that I got this data set, I'm going to shift the path so that I have only one GH path here, like this, which is equivalent to the number of surfaces here. Right. Okay. Now let's bring up the Voronoi and bring this point to this point of the Voronoi here itself. Now for the boundary, I want to make a boundary for each surfaces. So let's also create a surface boundary for each text surface which comes out of this graph. Let's make it simplify. And in order to make a boundary out of each surface, I'm going to first create a bounding box. And the bounding box creates a box, so you have like which just could be used inside the boundary input for the Voronoi here. But let's make sure that it covers all the parts of the points by scaling this up a little bit. So create area to get the centroid of the bounding box, then do a scale of the box with the centroid being the axis, and the factor something like 1.5, so that it will be always bigger than the outline. Now let's first of all check the data structures. If the pass number is same as this one, I have 31 path here, I have 31 path here, so that seems okay. Let's connect this one. And let's hide all these. And I think it seems to work fine here. Alright. Okay, just to make sure, I'm gonna set the plane here to XY plane. So it's this one. So connect this one here. Okay, now the next thing I would like to do is to trim this Voronoi curves, Voronoi cells with a text outline, just as I did here in number 3. Okay, to do that, I'm just gonna do a really simple simple component called, what was it? Project. This one. project with onto a B-rep. Project the curve onto a B-rep. Okay. So the curve that I want to project is this Voronoi cells. So place that to a curve, and the B-rep that I want to project onto is a text itself, text surface itself, so which comes from this graph. So connect that to a B-rep, and the direction as a default it is 001. That is fine. So let's keep that as it is, and if I hide these, now it already start to looks like an outline that we want. Now as you can see, you have unnecessary edges which is touching the outline of the text here. So next thing I would like to do is to remove those touching edges of the cell, so that I'm left with the center lines, center cores of the text outline. And if I decrease the size of the distance in between the curve, to divide the curve, you can have more high-res Voronoi makes the line more high-res as well, like this, more straight. Okay, so let's keep this to 0.5 something, and that looks good. Right, so let's try to remove the edges that is touching the text outline. In order to do that, first thing I'm gonna do is to explode the outline curve. I mean the curve from the cells, the curves that is projected from the Voronoi cells, so that every curve will be a line segment. Okay. Now that I have these curves, let's also simplify this Voronoi cell to add here. And let's look at the path structure here. Okay. Now to clean this up, let's create a path shift. Then I'm going to, now if you use the Voronoi cells, you might notice that if you do, you will get duplicate line segment for each segment, because the cell itself is looks like this, and each cell is like the closed cell curve. And if you explode it to the line segment, then you always have duplicate curve if the cell is connected to each other. So you want to remove that, and the easiest way to remove the duplicated line is to use a remove duplicate lines from a kangaroo component. So let's do that. Let's connect this. So in order to use this, you need to install a kangaroo, which is this one, kangaroo 2 or kangaroo 1. I guess kangaroo 2 is better. And inside the utility, you'll have this remove duplicate lines. So use that to remove the duplicate lines. And okay, I think I need to do one more shifting here. Okay, I think I'm missing something here. Okay, when I explode it here, if I simplify this, okay, Maybe this should be fine. The number of lines here and the number of lines here seems pretty much the same. Okay, maybe there is something wrong here. If I simplify this, let me try to bake this to check if there are duplicates. Okay, there is. So I guess I need to do one more shifting for this offset. I'm going to set it to -2. And let's see if this works. Yeah, I think this time it works. Now the question is if this still works even with one character. So let me test this out by using a one continuous surface like W. And if this still works, then that's good. Yeah, it seems to work. Right. Okay, that's good. Okay, now that I have got a unduplicated lines, next thing I would like to do is to use another C# component in order to remove those lines which is touching the outline of the text. So let's do that by creating a C# component. Okay, the first input names, I'm gonna name it as curves. And for the second, I'm gonna name it as outlines. Outlines. Okay. Let's connect those two together. And for the second input, I'm going to connect the one that comes out of this joined component. So, which is the outline. And let's set both types to be curve. Curve. Outline as a curve as well. And let's also set those two input as a list. So we want to do the calculation between the list and the list. If you look at the collection, if you look at the output from the remove duplicate line component, you have 31 paths, and for each path you have several line curves. And for the first path you have 152 lines. And for the joined curve, for the for the first path you have 2 outline curves, which should be, I'm not sure which one is it looking at, but yeah. So let's get inside here. The reason why the outline curves sometimes have 2 curves is that sometimes you have a hole like this, like the character E. You have the outline and you have the inside curve as well, inside outline as well. Alright. Considering that, let's write some code in order to remove the lines that's touching the outlines. So first of all, let's create a list, empty list of curves as an output. Okay, and I'm gonna look all I'm gonna look through all the curves, which comes from the duplicated, remove duplicated lines in for loop, like this, and for each, okay. And I'm going to check if one of the endpoint of the curve, which is the line, which should be the line curve. So I'm going to check if the endpoint of this line, either the starting point or the end point, is touching the outline of the text by using the function called closest point. So in order to check the closest point on a curve, first of all, I'm going to use the curve dot closest. Okay, it doesn't give me any hint here. Curve dot, what if I set this to curve dot, okay, now it works. Curve closest points. I'm gonna check with the outlines, and then as a result I would like to get the out, which is on the point on the curve, so PT on C as well as PT on object, so PT out, PT on object. And another output that I have to give is a out, which I don't think I'm gonna use, though I need to provide it. So let's create those out parameters here. First of all, point 3D PT on C, PT on object, and int which. Okay, let's see if I have any errors here. Nope, looks fine. Okay. Now the next thing I would like to do is to calculate the distance between the closest point on a outline and the closest point on the object, which is in between this one and this one. If the point on curve here and the point on object, the distance between those 2 points is close to 0, then it means that the point on a curve, it means that the curve is touching the outline in this case. If you say this is the curve that you're looking at and you want to check if it's touching this outline, then this curve is this one, right? And this outline is this one. And PT on C means that when calculating the closest points between this curve and this curve, the PT on C should be somewhere around here, which is laying on top of this curve right here. And the PT on object is the point that is laying on this outline that is close to the curve, so this should be around here again. So if the two curves is touching together, then the distance between those 2 points should be equal to close to 0. If the curve that you're looking at is this one, and you want to check the closest point between the outline, then the PT on C is either somewhere around here or here. And the PT on object is somewhere around here or here. So that means that the distance between those 2 points is more than 0. So that means that the curve is not touching the outline. So that's the way you can define if the curve is touching with the outline or not. So let's calculate the distance between those 2 points by using a distance2 function. And if the distance is close to 0, I'm just gonna create some threshold like 0.01, and then add those touching curves. Wait, you don't want to have the touching curves. You want to have the curve that it's not touching the outline. So if the distance is more than 0, then add the curve that you have found out, which is not touching the outline, inside the out curves. Then finally, I'll put this out curves like this. Okay, do I have any errors? Nope. Now let's hide those duplicate lines and see if I got the center lines, and yes, I seem to have it. Now if I hide all these curves before, I'm left with this curve, and so far so good. It looks already looking great, but I have one final problem, is that I have some kind of unnecessary ridge lines here. And if I look at the outline curve, this is actually not touching the outline, so this one wasn't removed. But obviously we don't want those kind of curves. We don't want that kind of ridge curves. We want to remove those. So that's the final step that we're going to do, and that's the most time-consuming coding part. But if you're done with it, you have more clean text core lines, a single line font, which you can use for many purposes. So bear with me. So in order to remove those ridge lines on the edge, we need to find some kind of pattern, what kind of ridge that we want to remove. And if we look at those ridges, there are some patterns that we can realize. Is that first of all, the ridge curves is always on the end edge of the curve, and the ridge always have 3 branches. It's connected with the branch which have 3 branches here. So if the edge is at the end point, and then if this end edge is connected with the branch which has 3 branches, then we can assume that we could remove those curve as well as this one. So applying that same rule for everywhere else, I think it still works. This one also is at the end point of the edge and is connected with the branching point, which have 3 branches. So let's apply that rules to actually remove those end ridge lines. And we could do that by using another C# component. Now, if you look at the data structures here, I think every curve exists right now is seen as a line, created as a line. So if I try to bake it, each line is made of a line here, like this. Right, so in order to remove those lines, what we need to know is whether first of all, you need to find the end point of the curve. And from this end point, you want to go back, you want to go through the connected line, until it hits some kind of branching point. And remove those curves until it touches the branching point, like this. And you gotta do it simultaneously, because if you delete one ridge lines first, then for the next one you won't be able to find the branching point. So you want to remove those two ridges simultaneously. You want to search it simultaneously, like a parallel. Okay, so keep that in mind, and let's do this. First of all, I'm going to create a another C# component, and let's set the first input to be lines, and I'm gonna set the type to be line as well. So line, and I am also going to set the list type to be list axis. Okay, and there are situations that sometimes you want to set the maximum size for how much you want to delete those end ridge point, because somewhere like here where you don't have any branching point, well, actually you have here, but let's say there aren't any branching point here. So if you don't have any branching point, then if you set the rule to remove all the lines until it touches the branching point, which have 3 branches, it just delete whole lines here until here. Now that is problematic at some characters, because for this characters you just want to delete somewhere around here. So in order to do that, you need to set some threshold to set it as a maximum size, how much it can delete as a total length of the end ridge lines. So together with those rules, together with the maximum length, you can actually create a function that can create a clean single line font or single line skeleton. So for the second parameter, I'm going to set it as, say, trim length. Okay, and I'm gonna set it to double. Okay, so first of all, I'm gonna connect this output lines to the lines, and then for the trim, I'm going to create a slider, custom slider like this. Okay, let's write some code here. So this one's gonna be a little bit long, so bear with me. The first thing I would like to do is to create some kind of node and connection pairs in order to get the information which points connect to which points with lines. So I am going to first create a list of points which exist on each curve, and then also create a neighbor information for each point, which point that point is connected. So for the neighbors information, I'm just gonna set the index of the point, index information of that point. Right, just like you do in graph theory. So first of all, let's create a empty points list. And then neighbor informations using integer. Okay, and for each line you want to find if one of the endpoint of the line is already inside this PTS list to check the connection. So let's name this result1 PTS find index, and using the link if the PTS distance, PT distance is equal to line, the distance between the P point inside the PTS list and the line from, which is the starting point, is less than 0.001, meaning it's touching, the distance is 0. Then, oops, this is not a condition. So if the result is less than 0, meaning negative value, then you couldn't find any touching point. Then you want to add this line from point. And for the neighbors, okay, I guess for the neighbors you want to have a list of integers for each point, so you need to have a nested list here. Okay, so for the neighbors you want to add a new list for added point. So first thing I'm doing here is to create a list of points inside this PTS which is not duplicated. Okay, and something like this. Right. Now do the same thing for line dot 2, which is the endpoint of the line. So let's copy this, paste this, let's name this res2, and change this to 2. And if the res2 is negative, then add this line dot 2, and for the neighbors just add a empty list of integers. Right, now that I have, after having all those process, you have points which is not duplicated, which is not on the duplicate position inside this PTS list. Now after this, I'm going to look through all the points inside the PTS by using for loop like this, and get the PT first. Okay. And now next thing I would like to do is to actually get the connection information from those point information together with the line information. So to do that, first I'm going to create a variable called a lines1 lines find all, and so I'm going to find the line which the line 2 point, which is the endpoint of the line, is close to this PT that you have just retrieved. If it's close, then the line is connected with this point, so the other endpoint of the line, in this case line.from, is the neighbor of this point. Yeah, so distance to PT is less than the threshold. So after I find all the lines that's touching this PT, I'm going through all the lines inside this A line. Okay. And after I get, okay, do I have something wrong here for lines? Okay, I'm missing parenthesis, right? Now if after I get this line, I want to get the index of the point of the A line dot from. So to get that, I'm gonna do another link function, pts dot find index p distance to a line from is less than 0.001. Okay, now let's also find if this index is already exist in the neighbors list of this PT by and only add the neighbor information if you didn't find any duplicated neighbor information. So neighbors at index I find index neighbor is equal to index So if you couldn't find any same index inside the neighbors with this index value that you find out, then you want to add that index inside this neighbors list. Like this. Okay. Now let's check if I got any errors. No. Right. Now I have to do the same thing for distance line dot from for this one. So let's copy this, paste it here, and let's name this A lines 2. Change this to from, and let's also change this to 2 and find index. This should be 2, and the other information I think I can just leave it as it is. Yep. Okay. Now at this point I want to check if the one that I'm calculating here is correct or not. So let's output this point list and the neighbors just to make it sure that I'm doing right. And as you can see, the neighbors is a list of the list, so nested list, so you cannot just output it as it is inside a C#. You need to output as a data tree, which is a bit which takes a bit of time to do that. So I'm just gonna output the first first index, the first branch of this list. So for the PTS, I'm gonna just get the first item, and for the neighbors, I'm just going to get the first branch. Now let's create an output B and see if I got any information. So the first one is the point information, and the second one is the neighbor information. Those neighbor information is the index of the point which the point is connected to. Now that I have the information with the list of points together with the neighbor information, I would like to get where I want to remove the point, which is on the edge, and until the branch until it's hit the branch stop, or until it reaches the maximum length of the whole length of the connected lines. So to do that, I'm first going to create a list of the point index where you want to remove. Remove point indexes as a list of integers. Okay, and I'm gonna go through all the points inside for loop. And I am going to get the neighbor information from the neighbors list. Right. And so first thing I would like to get is this point, right? And as you can see, those endpoint have some characteristics. Is that you have only one neighbors at the end of the point. It's not connected to any of the point, but it only connects to one next point. So to find that out, it's pretty easy. You just need to give a condition. If the neighbor count is equal to 1, then you already found that the point is at the end of the edge. Alright, now from this point that you have just found out, what you want to do is to loop through the next point, which is touching this point. So if the neighbor point for this point is at here, you want to go here. You want to jump from this point to here and delete the point that you have just visited. And from here to here, you just want to jump again and remove the visited point. Then jump to here and remove the point that you have just visited. And stop jumping at this point because you have just reached the branching point. So you want to do that kind of loop, and you don't know how many loops that you have here, so I guess you need to do kind of a recursive loop here. But to make it simple, I'm just gonna use while loop, which is sometimes it gives you a infinite loop, so be careful. Try to save it before you use that. Alright, so if the neighbor count is equal to 0, I'm going to first create a list of visited indexes. To store all the index which you have just visited. Okay, and let's also create a integer called count to use it inside a while loop, and get the neighbor point information, which is the first neighbor point, since you already have one neighbors for the first point. So if you're looking at this point, then the first NPT is the index number of this point, the neighbor index point number. Okay, and let's also create a variable to store the current lengths. So from here you have a length of 0, but if you jump 1, then you have some lengths added, and if you jump again, another length is being added to the current length, and another length will be added if you jump again. And if it reached to some maximum value that you have just set as a threshold, then just stop deleting the point. Start from 0. Okay, now first add the visited list with the current point index of this point, which is equal to I. So I'm just gonna add I here, right? Now here's the part that you want to use the for loop, the while loop, recursive calculation, to look through all the points until it touches the branching point, or until the length of the line reaches to the maximum threshold. So before doing that, first of all, I have some errors here. Okay, visited doesn't exist. Really? Okay, I guess I forgot to set variable. Okay, still 105. 105 is okay. Spell mistake. Visited. Count is not used. Current length is not used. Yeah, that's fine. Okay, before get it into the recursive calculation, let's save this file just to make sure you don't lose anything, because there are a great chance that you freeze this file out by using the recursive approach of while approach. Okay, let's go back to the code. And let's write the final code. So I'm gonna start with the while loop, true, and at some point if it reached to some condition, then break the loop. Now this doesn't do anything, I think. It's just go inside the loop and just break as soon as it's possible. Now I'm gonna start with this so that it will be safer having a break. Right. Now, first thing I would like to do is to get the neighbor information at specific NPT point. And then NPT is the one that is next to the first point. So if you started from here, this point, the NPT is the index number of this point. So if you have if you're searching for neighbors for this NPT index, which is for here, the neighbor index that you get is either this point index or this point index. And as you can imagine, you don't need to have this index because you don't want to go back. You're just gonna go forward. So you need to kind of ignore the one that you have just visited. So that's where you can use this visited list, right? So keep that in mind, and let's get in. Now first of all, if the npts dot count is not equal to 2, meaning it's either 1 or 3, then we want to break this. We want to break the loop. Meaning if the neighbors have 3 branches, it just reached to the point where you want to stop the loop. So you want to break it. Same for if the neighbor point is equal to 1. If the neighbor point equals to 1, then it just goes. If it was like one continuous line, then starting from the end point and go to the first point, then you also want to exit the loop as well. So you only want to run the loop when the neighbor count is equal to 2, meaning the point is in middle of the line connection. Right, so this is where you want to write the code, the main code here. So if the neighbor count is equal to 2, then first of all you want to get the previously visited index from the visited list here, just to make sure that you're not going back. So var previous position is equal to visited length or count -1. So this means is the last index which been added to the visited list, and using that index you are retrieving the point position. Okay, now npos equal to pts dot npt. Now npos is the current point position which you're looking at. So if you start from here, then the first neighbors is the npt, and the previous position here is the first point. And so you have the previous point and the current point position, and what you want to do is to calculate the distance between those 2 points to get how much distance you have just moved. So calculate the distance by prev pos.distance to and pos. Okay, and add this distance to the current length. And if the current length is less than trim, then continue doing the calculation. If not, break the loop. You want to exit the loop because it reaches the maximum. If it's not reaching the maximum yet, then add visited this current point position, point index, which is around here. Then do another loop for the neighbors at the NPT. Which is this one. So for int n equal to 0, n is less than npts dot count, and I'm gonna name this next npt, so tnpt equals to npts dot at n index. Right. Now for the next MPT, for the next loop, I want to find the next MPT, the next point. If you're looking at this one, I want to find this next point index and not this one. From NPTS, you have either this point or this point, but you only want to go to this point. And you can find that out by checking if the point index at here or here is already exist in the visited list. If it exists in the visited list, then you want to ignore that point. So if visited find index visit equal to tnpt, so if the point index, either this one or this one, already exists in the visit with this condition, then you want to ignore it. If not, then npt, next npt is this tnpt that you have just find out. Okay, should be good. And what else? After this, after all these calculations, I want to add the count by 1. Okay, and let's just left this break a little bit more to make sure we have, after we finish the whole stuff. Visited, okay, some spell mistake again. Visited. Okay, so far so good. Now, finally, I want to add the point that we want to remove inside this remove point indexes. So that could be done after this while loop. After we exist the while loop, then we going to look through all the visited indexes, and all the visited indexes is the one that you want to remove. So if remove point indexes, find index, visited is equal to visited, then if you couldn't find any visited index inside the remove point indexes, then add that index inside of remove point indexes list. Gotta do the end. Gotta use end for this loop. Okay, let's check. No errors. Okay, now's the time I can remove this break. Should work fine. Yeah, looks fine. Now I still have those points left. I still have those lines left because I didn't really done any removal function yet. I just got the information which point to be removed. So I think all those functions are fine. Now let's get to the final step. Okay, after I have left the whole loop here, I have this remove point indexes, and currently I think the index order is pretty random, so I'm gonna sort it to descending order of the point index. So make the highest index value to be comes first, so that it'll be much easier to remove using the inside a for loop. So remove point indexes, sort, then remove point indexes reverse, which should sort this indexes into descending order using the value. Okay, so after this, for each var index and remove point indexes. What I want to remove is the lines, I think, not the point itself. So, well, point as well, I guess. So first I'm going to get the point information, point position using the index, which should be removed, and find out the lines that you want to remove from this point position. So you can search it by whether the point is at that line or not. So var remove lines. If the line's endpoint is touching this point, then you might want to remove that. So line 2 distance to PT, or line from distance to PT is less than 0.001. Okay, now for each, for remove line inside remove lines, let's just delete at that position. Okay. And also we can remove the point from this index. Okay, finally I can output the point and the lines and see if we got the result that we want. Okay, let's see. Oops. What seems to be the errors? 151 PTS. Okay, I have to say remove at. Okay, going well. It seems like I have removed all the unnecessary points on the edge. And if I hide those, and if I just show the curve, everything seems to work just fine. We have just removed the unnecessary ridge edge on the end. Yep. And well, we kind of removed the point for the apostrophe. Now, in order to retrieve those X, we might need to reduce the size, how much size we want to retrieve. Like this. And well, if the value is too small, we still have this edges at the end, so I guess we need to find some good balance between retrieving those points and left out those endpoint here. Well, now it's gone. Yeah, this one was a bit hard. I guess for that, maybe I could choose another font. What if I choose the Arial black? Still the same. What if I choose number 5, bond script? Well, and maybe reduce the size here to 1. Maybe I still got this X. I guess it's because the original outline is too small, like this, too squared. Okay, let's try with the Japanese font, like 144. Well, I'm still missing something here, but well, that's okay. It's just about the threshold here. Just a matter of this threshold here. If you make it less, should be able. This one doesn't even show. Maybe the outline itself. Okay. Okay, so this is kind of a special occasions. It's circle, so it removed every lines because every line was touching the circle. Okay. Well, if you want to left something like this kind of conditions, then you want to have some special conditions here. But overall, I think it's working. and I am pretty much satisfied with it. And I think I still see some small lines here. Yeah. And if I show the point information, I still see some 1.1 or a few points here. Looks good, looks good. Now for the final touch, I can smooth out a little bit because as you can see, because we use the Voronoi to get the ridges, the line itself is not that straight. So to make it a bit more straight, a bit more clean, I am going to do some final touch up. First of all, I'm going to get the control points and then get the number of control points here and then divide it with value like 2 and maybe set the minimum to be something like 3 and then use that value to resample. No, what was it? Forgot the name. Rebuild. Yeah, rebuild. Rebuild curve. Okay, and I want to rebuild this curve. I guess before rebuilding the curve, it's also a good idea to join them, because currently this is just a line, list of lines, so make it as a polyline first, then rebuild it using a degree of something like 3 to make it smooth, and reduce the count of the point number by using this calculation, which makes the whole curve a bit smoother, a bit more straight. Oops, that was too much, I guess. Okay, I see what's wrong. I think this is what was wrong. I need to use maximum instead of minimum. Sorry for that. Okay, that looks better. Okay, and a bit smoother than before. And overall, that looks good. So it was a bit long video, but this is how I have managed to get the skeleton out of the text as a core line, and to make it as a single line font. I think the usage of this could be this could be used for many purposes. I hope you find this somehow helpful. And that's it. I hope you have learned something new here. The algorithm itself is pretty simple. The implementation is a bit long, but still, I guess you can count it as a simple algorithm. Right, that's it. Thank you for watching, and please give me any feedback. Anything is welcome. Okay, that's it. Goodbye.